Hello everyone, myself Vinay Kumaram. I am pursuing PhD in physics. So in this particular YouTube channel, I'll be teaching physics, chemistry and mathematics starting from 8th standard till 12th standard. So if you want to learn physics, chemistry and mathematics, then please do subscribe to my channel. So in my previous videos, I was actually explaining exercise 8.2 questions, which is there in the 8th chapter of 9th standard mathematics based on quadrilaterals. So in those videos, I had actually explained first, second, third and fourth question in this particular exercise. So in this particular video, we'll look into the next remaining questions, that is fifth and sixth question in this particular exercise 8.2. So in fifth question, we have a particular parallelogram. So let us draw a parallelogram here. So we have one parallelogram A, B, C, D. So in parallelogram, opposite sides are parallel to each other and opposite sides are equal to each other. So here F is the midpoint. First, let's name this particular parallelogram, that is ABCD. So for this DC, F acts as the midpoint, and for this AB, E acts as the midpoint. And here, starting from A, this particular F is connected. And starting from E, this particular C is connected. So now, here they have given a diagonal DB like this. So let us connect D and B. So this point is named as P and this point is named as Q. Now you need to prove that DP is equal to PQ is equal to QB or not. So that means basically these two lines, that is AF and EC, are trisecting DB. That is, it is dividing DB into three equal parts. That is, DP is equal to PQ is equal to QB. That is what we need to prove here in this particular question. So in order to prove this, first we'll consider this particular quadrilateral which is there inside. So I'll just write that particular quadrilateral which is there inside like this. So we have one quadrilateral. So this is F. So this F is there and C, E, A. So in this particular quadrilateral, AE is parallel to FC. And we don't know whether AF is parallel to EC or not. So now we'll write consider quadrilateral. So consider quadrilateral FAEC. So here in this particular quadrilateral, we know that opposite sides of a parallelogram are equal to each other. So that means if we consider parallelogram ABCD, AB is equal to DC. So consider quadrilateral FAEC. So this will just keep it aside. So now in parallelogram, ABCD, AB is equal to CD. Or you can write this as AB is equal to DC. So AB is equal to DC in this particular parallelogram ABCD because opposite sides are equal in parallelogram. So now F is the midpoint of DC and E is the midpoint of AB. So that means here since F is midpoint of DC, so here since F is midpoint of DC, so therefore here FC is equal to half times DC. Similarly, E is midpoint of, so we'll call this as equation 2 and this as equation 1. And here similarly E is midpoint of, since E is midpoint of AB, therefore AE is equal to half AB. So here this we can call as equation 3 and we know that from equation 1, so from equation 1 we have AB is equal to DC. So therefore equation 3 becomes AE is equal to half DC. So in the place of AB, I'm replacing this AB with DC because AB is equal to DC. Now we can call this as equation 4. Now we'll write this equation 2 and equation 4 together. So in equation 2 we have FC is equal to half DC, and here from equation 4 we have AE is equal to half DC. So we have RHS getting equal to each other. So therefore FC is equal to AE. So that means here we have proved that this particular FC is equal to AE. So now we have FC is equal to AE. So why we are proving FC is equal to AE is because in order to check whether AF is parallel to EC. So now because we have proved that FC is equal to AE, so that means from F to C and from E to A, there is same distance. So that means AF and EC are at equidistant from each other on both the ends. So that means here AF will be parallel to EC. So here since FC is equal to AE, therefore here these two lines, that is AF and EC, that is these two lines AF and EC will be parallel to each other. So here therefore AF and EC are at equidistant at both ends, at the both ends. So therefore AF is parallel to EC. So therefore AF is parallel to EC. So first you need to prove AF is parallel to EC, and then you can consider a triangle here. That is this particular triangle you can consider, that is A, B and P. So this particular ABP triangle you can consider. So let me draw that particular triangle over here. So we have a triangle like this. So here this is A, this is P and this is B. Here we have E as the midpoint of AB, and here this point where it is crossing over this DB, this they have named as Q. So here we have proved AF and EC are parallel to each other. So if you extend this AP, it will go up to F, and if you extend this particular EQ, this will reach C. So that means here we have proved AF and EC are parallel to each other. So that means here EQ is parallel to AP because Q is lying on EC and P is lying on AF. So here consider triangle. So here let us consider triangle APB, and we know that AF is parallel to EC. So therefore AP is parallel to EQ. So therefore AP is parallel to EQ because AF is parallel to EC and P and Q are lying on AF and EC. So AP is parallel to EQ, and E is the midpoint, and E is the midpoint of AB. So we know that E is the midpoint of AB. This is already given. This is already they have given in the question. So E is the midpoint of AB and AP is parallel to EQ. Therefore here Q is the midpoint of PB. So therefore Q is the midpoint of PB. So this is according to theorem 8.9, or you can write this as converse of midpoint theorem. So in order to understand midpoint theorem and converse of midpoint theorem, you can refer my previous videos. So Q is the midpoint of this particular PB. So since Q becomes midpoint of PB, so PQ will be equal to QB. So since Q is the midpoint, therefore PQ is equal to QB. Now we will call this as equation 5. Now we will consider this particular triangle. So we will consider this particular triangle, that is DQC. So now we will consider this particular triangle, that is DQC. So here we have, inside DQC we have this PF line also, and F is the midpoint of DC. So here F is the midpoint of DC, and you can draw a line like this. So this particular point is P. So if you just extend this, it will reach up to A, and if you just extend this, it will reach up to E. And we know AF and EQ are parallel to each other, so that means PF and QC will be parallel to each other. So consider triangle DQC. So in triangle DQC, and we know that AF is parallel to EC. So since AS is parallel to EC, therefore PF is parallel to QC. So here PF is parallel to QC. How we did in this particular case? Similarly, we are doing here also. So here PF is parallel to QC, and F is the midpoint of DC. F is midpoint of DC. This is already they have given in the question. So since F is midpoint of DC, therefore, so here you can see F is acting as midpoint of DC, and this particular line and this particular line are parallel to each other. So P should be the midpoint of DQ. So therefore P is midpoint of, so P is midpoint of DQ. This is according to converse of midpoint theorem, or simply you can call this as theorem 8.9. So now we got P as the midpoint of DQ. So that means here DP will be equal to PQ, or you can call PQ is equal to DP. So PQ is equal to DP. So now we have got PQ is equal to DP. This you can call as equation 6. So if you see equation 5, we have PQ is equal to QB, and from equation 6 we have PQ is equal to DP. So therefore PQ is equal to QB is equal to DP. So if you compare equation 5 and 6, PQ is equal to QB is equal to DP. Therefore at last you can write the statement that the line segment AF and EC are trisecting this diagonal BD. That is PQ is equal to QB is equal to DP. So BD is now divided into 3 equal sections. So that's why it is known as trisection of BD. That means all 3 sides are equal to each other. PQ is equal to QB is equal to DP. So this is what they asked in this question to prove, and we have proved that. Now we will look into the next question in this particular exercise, that is 6th question, and this is the last question in this particular exercise. So here they have given ABC is a triangle right angled at C. So they have not given the diagram. So we need to read the data what they have given, and we have to draw the diagram. So let us draw a right angled triangle. So at C, this right angle is there. So this you can name as A and B. Here a line through the midpoint M of hypotenuse AB. So now the AB is the hypotenuse. So here this is the midpoint of AB, and this is named as M, and from that M a line is drawn parallel to BC. That is, they have drawn a line parallel to BC which passes through this particular point M, which is the midpoint of AB. So this line is parallel to BC. So now this line what you have drawn parallel to BC will intersect AC at the point D. So that means this point is named as D. So now we have a diagram like this. So we have created this diagram based on the data which they have given. So based on this, there are 3 questions in this 6th question. You have to prove those 3 things. So in first question, they have asked to prove D is midpoint. So D is midpoint of AC. We need to prove, and this is very, very, very straightforward question, because here already we know DM is parallel to AB, and already we know M is the midpoint, and according to theorem 8.9 we can straight away tell that this D is the midpoint of AC. So there is nothing to solve in this first question at all. So here in triangle ABC, M is the midpoint of AB. M is the midpoint of AB, and DM is parallel to BC, and DM is parallel to BC. Therefore, D is midpoint of AC. So you can just write this statement and you can conclude that D is midpoint of AC, and reason you can tell converse of midpoint theorem, or straight away you can say theorem 8.9. So according to theorem 8.9, D is midpoint of AC. So now we will look into the second question in the same sixth question. Here you need to prove MD is perpendicular to AC. So here you need to prove MD is perpendicular to AC. So in order to prove MD is perpendicular to AC, you need to prove that this particular angle is equal to 90 degree. So in order to prove that, you can just write this particular DM line, and you can write this particular CB line. So here we have CB line and here we have DM line, and there is one line like this. And we know DM is parallel with BC. So these two angles acts as corresponding angles for the parallel lines. So here since DM is parallel to BC, and here it starts from A, so and AC acts as traversing line. So AC acts as traversing line for DM and BC. For both DM and BC, AC acts as traversing line. Therefore, ADM is equal to DCB. This is because they both act as corresponding angles. So corresponding angles are equal in case of parallel lines. So corresponding angles. So in previous chapter, we had studied lines and angles. So you can refer those videos. In parallel lines, corresponding angles will be equal to each other. Alternating angles will also be equal to each other. So here these two angles acts as corresponding angles, and they are equal to each other because DM is parallel to BC and AC acts as the traversing line. So, and we know that DCB is equal to 90 degree because this is the right angle triangle. So at C we have 90 degree. This is already given in the question. So, and we have proved ADM is equal to DCB. So therefore DCB is equal to ADM is equal to 90 degree. Since ADM is equal to 90 degree, MD is perpendicular to AC. So here MD is perpendicular to AC. This is because, so therefore MD is perpendicular to AC. This is because ADM is equal to 90 degree. That's it. Now we will look into the third question in the same sixth question. So here you need to prove CM is equal to MA is equal to half AB. So here CM is this particular line. So you need to connect C and M. And here MA is also there. So that is this particular line. So CM is equal to MA is equal to half AB. This is what you need to prove. Here already MA is equal to half AB. So here MA is already equal to half AB because M is midpoint of AB. So since M is midpoint of AB, MA is already equal to half AB. So now here in this particular diagram, we will consider these two triangles. So here we have this triangle. So we'll consider this triangle ADM, and we'll consider this particular triangle DCM. So I'll just write those two triangles over here. So here basically we have two triangles like this, and one line is there. So this point is D, this point is A, this is M, and this is C. Now we know AM is already equal to half AB. We need to prove CM is also equal to AM, so that CM will also become equal to half AB. So in order to prove that, we'll consider these two triangles where this particular side is already equal to 90 degree, because we have proved ADM is equal to 90 degree. So this particular angle, that is CDM, will also be equal to 90 degree because they act as linear pairs. So consider triangles ADM and triangle DCM. So in these two triangles, we already know ADM is equal to 90 degree. This we have already proved. And here CDM is also equal to 90 degree. This is because of linear pair, because here AC is a straight line and DM is a straight line. So that means here this particular angle and this particular angle, if you add, they should be equal to 180 degree. So if one angle is becoming 90 degree, then other angle will become 90 degree. So 90 plus 90 will be 180 degree. So here ADM and CDM are linear pairs. So if ADM is equal to 90 degree, then CDM is also equal to 90 degree. Therefore ADM is equal to CDM. So, and DM is common side for both the triangles. So here DM is equal to DM. This is because they act as common side. This particular side act as common side for both the triangles. Now here this particular AD and DC are equal to each other. So here AD and DC are equal to each other because D is the midpoint of this particular total triangle ABC. So if we extend this particular line and if we extend this particular line, we had a triangle ABC. So here M was the midpoint of AB, and here DM is parallel to BC. Since DM is parallel to BC and M is midpoint of AB, here D is also the midpoint of AC. So that we can write. So in triangle ABC, M is midpoint of AB. So M is midpoint of AB. So M is midpoint of AB, and DM is parallel to BC, and DM is parallel to BC. Therefore D is the midpoint of, so therefore D is the midpoint of AC. So D is the midpoint of AC. This is according to converse of midpoint theorem, that is theorem 8.9. So since D is the midpoint of AC, therefore here AD will be equal to DC. So that means here we have proved this particular angle and two sides across that particular side, that is AD and this particular DM, are equal to DM and DC. So here AD is equal to DC, and here middle angle, that is ADM, and this particular angle is getting equal to each other. So next corresponding side, that is DM, is acting as common side. So that means here according to SAS congruence theorem, so here we have got AD is equal to DC, and we have got ADM is equal to CDM is equal to 90 degree, and we have also proved that and we also know DM acts as common side. So according to SAS congruence, so therefore according to SAS axiom, so according to SAS axiom, here triangle ADM is congruent with triangle DCM. So since triangle ADM is congruent with triangle DCM, therefore AM is equal to CM, or MA is equal to Cm. So we know that MA is equal to half AB. So we know that MA is equal to half AB. This is because M is midpoint of, so this is because M is midpoint of AB. Since M is midpoint of AB, MA is equal to half AB, and we know that MA is equal to CM. So therefore, MA is equal to CM is equal to half AB. So this is what they had asked to prove in this particular sixth question, and we have proved that. This is all there in this particular video. This comes to the end for this particular 8th chapter in 9th standard mathematics. So quadrilaterals chapter is completed by now. So in the next video, I'll start the new chapter that is on circles, which is the 9th chapter in 9th standard mathematics. So until then, if you want to learn more physics, chemistry, and mathematics starting from 8th standard till 12th standard, then you have to subscribe to my channel. Please do subscribe to my channel and stay tuned with my channel. Thank you.